Hi, Assalamualaikum warahmatullahi wabarakatuh. And how are you? Here's I am. I want to present to you about ECE521 microprocessor system for our lab 2 input output programming in ARM assembly language. So we got question 1 for this lab, which is running light control using slider switches. So you guys must wondering how this running light control using slider switches. So we gotta find out. So before we go to the question, I want to introduce you to some of my friends. So here's my members for this lab. First, I got myself, Muhammad Araf bin Arsham, and then I got my fellow friends, Muhammad Amar bin Abdullah Samawi, and then my other friends, which is Muhammad Daniel Hakim bin Nurul Shahrazi. That is our members. So without further ado, we go to the next, which is our objective. So here's our objective for this lab. Uh, for this lab 2, we conclude that we got three objectives that we need to achieve from this lab. Firstly, we got to familiarize with CPU letter simulator. And then we got to understand memory method, input or output. Then lastly, we got to observe the interaction between slider switches and LEDs in CPU later. So all these three objectives that we conclude for our lab, we need to achieve at the end of our lab session. Then we go to our question. So here's our question, which is question 1 we got for this lab. As stated that write and execute an assembly program that turns on LED R0 to R9 on one by one from LED R0 to LED R9 as running light when the switches SW2 is pressed. Next, when the switch SW4 is pressed, the LED R9 to R0 turn on one by one as running light. So if you guys not understand well to the question, here's I got some for you. So here's we got two condition, which is SW2 is pressed and SW4 is pressed. So what happened when SW2 is pressed? So the action of the program will LED R0 from LED R0 to LED R9. It will turn on one by one and it will call as forward running light. So in the program, if you turn on switch 2, it will turn from 0 LED 0 to LED 9. And then the second condition we got is switch 4 is pressed. When switch 4 is pressed, the program will run from LED R9 to LED R0, turn on one by one, and it will call reverse running light. So that is our lab for this ECE521. Then we go to our flowchart. So here's our flowchart of this lab. So firstly, we start the program and then we need to initialize to our main in this lab, which is LEDs and switches. So for the LEDs, I stated as R0 and then I put the value of 0xFF200000, and for the R1 as a switches, I put the value 0xFF20040. And then for the R3, what is R3, right? R3 is for the LED to turn off, so I put the value 0 there. Okay, and then we go to the next. It's write 0 to LED register, turn off all LEDs. So what is that? So basically, when the a light is run from 0 to 9, it will have some delay time. So it will 0 turn on, and then 1, and then 0 will turn off, and then 1 is turned on. So that is why I put the right 0 to LED register, so it will turn off when it had a delay there. So then we go to the next, which read switch values R4 to the R1 memory. So this is we put memory address to register R4. So we set data value there. And then as I said that we got two condition of this lab. So first condition we got SW2 express, and second condition we got SW4 express. So first we go to the SW2 express. So when SW2 express, is it press? If no, it will go to the no relevant switch press. What does that mean? It will keep scanning whether you are pressed or not. So if you press, it will automatically detect that you press that. Okay, and then it will, if yes, it will go to the forward running light, which is I said that it's from R0 to R9. LED will turn on one by one. So I said. So the next is turn on a current LED, which is we start as R0, and then store the value to R2 LED register. Okay, so next we got short delay. That is what I said earlier. It had a short delay for the LED to turn on, and then we'll go to the move to next LED. So R0, firstly R0 is turned on, okay, and then it store the value to R2 register. R0 LED turn on, the value we store it in on R2, and then it had some delay, and then move to the next LED for the R2, and then finish. No finish because we just go to 1. It needs to go to the R9. So 1, so no. So when no, it will turn back to the turn on current LED, store R2 to LED register. So we'll turn on R1, LED R1, and then it will store the value to R2. And then it will short delay, move to the next LED, finish, no, because currently we on R1 LED, and then we will go back to turn on current LED, which is we go to the LED R2. It will turn on and store the value to R2, and then we will keep repeating until we go to the LED R9. So if LED R9 is already achieved, finish, yes, finish. So go back to scanning, which is scanning is make the board steady and ready. So if you press switch 4 right now, it will go to switch 4, and then switch 4 is press no, so it will go to no relevant switch press, keep scanning. If yes, it will go to backward running light. So what is backward running light? As I stated, backward running light is LED R9 to LED R0 will turn on one by one. Okay, so it will go to turn on current LED, store R2 LED register. So it will turn R9. For the switch to press, it will turn on R0, LED R0, but this is reverse running light, so it will turn on LED R9, and then it store the value of LED R9 to the R2, register R2, and it will go to the short delay and move to the previous LED and finish. No finish because we only R9, we need to go to the LED R0. So it will go back to turn on current LED, which is current LED is LEDRA. So it will keep repeating until we got to the LEDR0. So finish when LEDR0 is turned on, finish, yes. So it will go back to scaling. So that's it for flowchart, and I will give you to my fellow friends, Amma. Thank you.
Hello and good morning to everybody. So I'm here to explain about the coding. So as we can see from the line 3 and 4, register R0 is loaded with the LED address and register R1 is loaded with the memory address of the switch. So for the line 8, store R3 into R0. So we do this to make sure that the value of LEDs remains 0 for the whole loop. Then we look at line 9, LDR R4 R1. So this is for the left binary states of all 10 sliders in the switches, and we're gonna store it into register R4. Then we look at line 12 and 13. So we have to check if switch 2 is uh, active or pressed. So we put it with hashtag 0 times 0004. So if the switch is open, it will trigger the start forward animation. Start forward. So then we look at 17 and 18, line 17 and 18. So we compare the R4 with hashtag 0 times 0010. So if the switch 2 is actually closed, it will directly start backward routing. Then we look at the start forward sequence. Move R2 hashtag 1. When moving forward, we initialize register R2 with a value of 1, which in binary translates to 0000 0000000001. So this actually represent lighting up LED R0 only. So for the line 28, left shift R2 hashtag 1. Inside the loop, we send this as our delay function. Then execute the left shift. This pushes the one to the next column. For instance, we have the first one, which is LED R0, 0000 0000 0001. Then we push it, and it becomes 0000 0000 which is LED2. So for the line 29, LDR R7 equal to 0 times 0400. So if we want to stop the loop, we have to check if R2 has reached 0 times 0400. This means that the last LED, which is LED9, is actually has been light up. When it's light up, so the condition is met and the loop breaks. So for the next sequence, we have to look at the backward sequence from LED9 to LED0. So we put LDR R2 equal to 0 times 0200, which is LED9. So when it's run back, so the first LED to light up is LED9. Then we leave, instead of shifting left, we execute the shift right, so that our one will be shift downward, so that just like before, from 0 0 0 0 0 0 0 0 0 1 0, then it becomes 0 0 0 0 0 0 0 0 0 0001. Then when the whole thing, the whole LED sequence is been light up, the and it equals to 0, the loop finishes. Then we look at the delay. So move R6 times 0 times 10. So this is for the delay. Then we subs R6 hashtag 1. This one is for subtracting our R6, our counter on every pass. This is to check if the zero flag is high or low. Then we have line 47, which is B and E lagi. The branch not if not equal, it will check the zero flag as long as R6 is not zero. So the CPU will loop again. So until it becomes zero. So on the 16th pass, R6 will hit zero. Then the zero flag will become one, and the branch not if not equal will fail. The loop breaks, and this will be the end of our coding. Now we look for the before and after the code is executed. So we have the first one, a load R0 equal to 0x FF 20000000. So this is for the LED address. Then we have load R1 equal to 0 times FF 20000040. This is for the switches. Then we have move R3 hashtag 0. This is for the clear constant so that the LDD will always remains closed. Then we have store R3 R0. So this is for our constant also for the LED to remain closed. Then we load R4 into memory address R1. So this is uh, so the R4 will hold the exact value of our switches. So if we press switch 2, R4 will become 0 times 0 not 0000 as we said. Then we have R5 and R4, which R4 is contain 000004 when the switch 2 is pressed. After we compare it, the zero flag will come up with one. That uh, so when this is the flag is triggered, so it will go to the start forward routine. So it is for the next table. As we can see, the trigger when the switch 2 is pressed. So we have move R2 hashtag 1. So R2 represents the LED 0, which is 1. Then we have store R2 into R0. So this is as I said, this is the LED's address. Then we have left shift R2 hashtag 1. So this when the shift left happen, and from the LED 0 lights up, then close, then the LED 1 will light up, and so on. Then we have compare R2 and R with R7. So both of them will be the same because after LED 9, which is 0 times 200 will be open and then close and become 0 times 400. So both of them are the same, and the zero flags will be triggered. And now we'll be looking for the before and after the code was executed. but this time is when the switch 4 is pressed. So we have load R2 with 0 times 0 200. So this is for the LED 9. So when the switch 4 is pressed, the LED will be light up backwards from LED 9 to LED 0 rather than LED 0 to LED 9. So then we have store R2 instead of memory address R0. So this is also for the LED memory of the LEDs. I'm sorry. Then we have shift right R2 hashtag 1. So as I said, 0 times 0 to 100, which is the LED 9, will be shift left by 1. Then it will become 0 times 0 100, which is LED 8. Then it will be shift again to become LED 7 and so on. So then we will compare R0 with hashtag we compare R2 with hashtag 0. This is for when the whole sequence is done from LED 9 to LED 0, then the value will be 0 and will be compared to 0. So the 0 flag will be triggered and the loop is done. Then we'll be looking for the next table, which is move R6 with hashtag 0 times 10. This is for the delay. Then we will look at the next line, which is subtract R6 with 1. So R6, which is we know 0 times 10 there, and will be subtracted by 1, then become R6 equal to 0 times 0F. And this R6 will be subtract until it becomes 0. Then the 0 flag will be 1. Then the loop will break. Now we are going to look at our simulation. So this is our coding after you compile. I'm going to run it now. And as you can see, there is no LED light up when there's no switch press. And I'm going to press switch 2 now. There is LED 0 from LED 9 will be light up. And now I'm going to change to switch 4. As you, then LED 9 will be light up until LED 0. Now I'm going to turn to LED 7. As you can see, no LED will be light up. This means our coding successfully complete according to the objective. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Hakim, and I will present to you about result, discussion, and conclusion. From the beginning, Araf said there was two action and two condition, which is the conditions are switch 2 and switch 4, and then will be resulting the actions. As you can see here, the switch condition, whenever there is no switch press, there will be no running lights. And when switch 2 is pressed, the LED from R0 to R9 will be start running. Whenever we switch to switch 4 is pressed, LED R9 to R0 will be running backwards from 9 to 0. Alright, moving to discussion. The program successfully controlled the LEDs using memory map IO in CPU later. When switch 2 was pressed, the LEDs turned on sequentially from R0 to R9, creating a forward running light effect, resulting to LED behavior switch 2. When switch 4 was pressed, the LEDs turned on from R9 to R0, producing a reverse running light effect. The result shows that the program correctly read the switch inputs and generated the required LED output patterns. And now moving on to our conclusion, which is the objective of the experiment was successfully achieved. The simulator was used to develop and test an ARM assembly program that interacts with memory map I/O devices. The program successfully controlled LED R0 to R9 based on the states of switch 2 and switch 4, producing the required running light patterns. This experiment improved understanding of CPU later, memory map I/O, and ARM v7 assembly programming. And that's all from us. Thank you very much.